we shall continue our study of structures, and we have seen in the previous day that structures are used for encapsulation of data so that they are represented in a more comprehensive format. And the examples which we saw for a student record, one way of declaring a structure variable, this is a structure variable, was struct, and then within brackets you define the structure of that variable, and this is the name of the variable. And as soon as you declare this name, this area will be allocated to this name. The area corresponding to 25 characters plus 8 characters plus 8 plus 8, 16 floating point numbers will be allocated to this student record. Other than pure variable structure declarations, you can also define structural types and define structures based on these types, which we also saw. That is, first you declare a structural type. Here we declare a structural type studrec, which was a student record, and here we defined all these 25 characters, a roll number of size 8, float SGPA 8 and float CGPA 8, and the name of this structure was called studrec, and this is a type declaration and not a variable declaration. Like integers, characters, etc., this is a declaration of a particular type. And if you want to declare variables of this type, you have to write struct studrec. So 3 variables of this type were declared. Here again a variable array student of size 200, where each element is of this type struct studrec was defined. An alternative definition of types is by the type def mechanism. Here the other way of writing it is type def struct, and the name of the type comes here. This is the name of the type. Now this is slightly more versatile than the other type, because here another name can be put in, and the utility of putting another name here we will see when we come to self-referential structures. And in order to use this type definition, we saw that you have to just write studrec stud1, stud2, stud3, or studrec student 200. So this is how you can declare structures, and they are used for data encapsulation. Now we will see a simple program in which we will use structural definitions to perform what is called encapsulated programming with such structures. And this program is just to highlight how structural types, that is, you can define new data types using structures, and you can write functions to operate on these data types, and we will work on complex numbers. So our intention is to write a C program which will be capable of defining a type for complex, like integer, real, character. We will define a complex type, and once we define a complex type, we will define functions to read a complex number, write a complex number, and also add 2 complex numbers. And this will show you how we can write it out in an elegant way, and how we can define new types in our programming language. So our structural definition of a complex number which contains a real and an integer, we will see, we will put in a type def int real and int imaginary, and call this type complex. So this is the type declaration. We have defined a complex type. In order to declare some variables of type complex, all that we have to do is write complex A, B, C. Now each of them will be a variable whose allocation will be one real one integer for two integers will be allocated to each of them. So now we have been able to define a new type called complex. Now we have to also additionally define our functions. How will we define the structure of a function which adds complex numbers? The structure of a function which adds complex numbers, say the function is called add complex. What will be the two arguments? One will be, this will be of complex type, this will be of complex type. Two elements of type complex it will take, and what will it return? What type? It will return another complex type. So now, using such type definitions, we can return from functions structures as well. Similarly, if you want to put in right complex, then it will just take in a complex type and print it inside the function. Finally, read complex. So it will return nothing. You can write void or integer or anything, or you need not write anything. In general, if you want to make it complete and that to indicate very clearly that it does not write anything, return anything, you write void. Now coming to read complex. Can you tell me what read complex will take? Will it take a complex as argument? It will take the address of a complex number as argument. So an address of a complex number can be written as pointer to a complex. If you remove the variable name, all you are left in the structural definition is like this. Suppose you want to write down a complex declaration, you write this. Suppose you want to write down P is a pointer to a complex number, then how do you write? This means P is an address of a complex number. This is the address, this is a variable, alright, but it will take the address of a complex number. So its definition is complex star, the address pointer to a complex number. So these are the three definitions that we will have, and now we are left to write down these routines. Add complex. It will take in two arguments, complex A and complex B. You could have also written AB and written here complex A comma B in that same way. We just wrote it out this way. And what would you do? You would have to declare some place where the real and the imaginary parts would get separately added. So we require a temporary variable where to store this. Either you could do it this way, so you could declare a complex temp, and write temp dot real dot. For a structure, this is the structure name, isn't it? For a structure name, you use this is equal to A dot real plus B dot real temp dot imaginary is equal to A dot imaginary plus B dot imaginary, and return temp. So the intention of showing this is that how we have used a complex type is just as a pure type definition, and inside the function we have computed the value, because now inside the function you need to know the structure of the variable, and using that structure we have computed the function. Anybody else who uses a complex type and wants to add two complex numbers will only call this routine, will need not access the internal portions of this structure. Write complex is obvious. Now let us come to read complex. Sorry, this will be A, and A will be a pointer to a complex number, or you could have written here complex star A also. Here it is, A is a pointer to a complex number, just like you had written int star A when you did the swapping of two numbers. Now let us note, A is a variable, alright. This is a variable whose, now in order to understand this, let us be very clear. This is a variable, so a variable will get a storage location, and the content of this variable is what? Suppose the content is 578213. This content is the address of a complex number. So this content is the pointer to a complex number. So if there is a complex number which starts from 578213, then this variable A will contain this location. And if you write A plus 1, this will jump by the size of this complex number. The increment will be made according to the size of this complex number. Alright. So if you write, if the complex number is of size 2 integers, which is say 8 bytes, then A plus 1 will increment it by 8 bytes. So if you have a variable which points to an integer, incrementing that variable will increment it by that many bytes. If it points to a character, it will increment it by that many bytes. If it points to a structure, it will increment it by the size of that structure. So we must first remember that when you declare this complex star A, this is a variable, but data according for this is only here, this will come as an argument. Now we have to read in two numbers. Scanf, let us read in the first one. We would normally, in our normal mode, we would read like this. A dot real, sorry, this is percentage D, if we define it to be integer. But this will not work. There is this A dot real works when A is of type complex. If A were type complex like this, then A dot real is to access this number. But since A is a pointer to a complex number, there is a difference between being a complex number. If it was a complex number, then its address would be the value of this. The address of A is different from the value of A. Here, since A is a pointer to a complex number, A will also have its address and value. its value is a pointer to a complex number. Whereas when you write complex A, the address of A is a pointer to the address of the complex number. So when you write this A dot real, this you have already got the address. In order to do it for such as declarations, you have to write this will take the content, and from that content whatever value it gets, now it has got the address. So there is a difference between A dot real and this is used when you have already got the address, and this is used when you have got a pointer to the address. All right. So you will do a scanf of this, a scanf, and return, and automatically inside A these values will be modified. So is that clear? So let us now see the final version of the program on the machine. So here we have got the include definition, and look at it, outside the main we have defined this, because this declaration is a global declaration. This declaration is a global declaration outside the main, and before the main we have used these functions, and we have also defined the structures of the functions outside the main. This is because the structures, these functions can be used in the main, they can be used at other places, and they can each can use the other people also. So in order to define the structures of the functions ahead, you can define them by just defining their type declarations. We have made no variable declarations, please note. Here type def, I have taken float real and float imaginary and called it complex, and I have defined complex add. Add returns complex, add complex, first argument is of complex type, second argument is of complex type. Void read complex, it has got only one argument which is the pointer to a complex type, and void write complex, it has also got one argument which is a complex type. So there is a difference between giving an argument which is the pointer to a complex type and a complex type. And in the simple main program we have declared three complex numbers A, B and C. Because this type definition is global, it can be used anywhere in any function. On the other hand, if you had defined this inside this main only, you would have had to redefine it in the functions. And then read complex and A, just like if it were an int. What I wish to stress here is that we have defined a new type, and you will use it just as you use the other types, and A. Again another one, read complex and B, C is equal to. Now this returns a complex type and is assigned to a complex number. A, B, and then write complex C. So we have defined a new type called complex, and we have used this type, and assignments can be made between elements of the same type structure directly. So add complex is just as we discussed, complex temp, temp dot real equal to x dot real plus y dot real, temp equal to imaginary, temp dot imaginary equal to x dot imaginary plus y dot imaginary, return temp. right complex has been made a little colorful in order to define that plus j. So right complex, X is of complex type, we define a character array of 3 characters and we assign, that is a string of 3 elements, and C is assigned, initialized to plus j, and we say if x dot imaginary is less than 0, C0 is made minus, alright, and x dot imaginary is equal to minus x dot imaginary, just to, and we printed it. To print it, we print out x dot real, this C which prints that plus j, and x dot imaginary. And complex, read complex, as we mentioned, this is defined as a pointer to a complex number, and scanf, oh I am sorry, I made a mistake, this x real, this part, this will give you the value of the real number, isn't it? X pointer dot real will give you the value of the real number. If you want the address of the real part only, and you have to use scanf, in scanf again we have to pass the address, in scanf we have to pass the address. If you want to do scanf of an integer x, you have to pass the address of that integer. If you want to do scanf of a floating point number, you have to pass the address of that floating point number. On the other hand, x pointer dot real will give you the content of that. If you want to get the address of that location, again you have to give the AND. Here x pointer dot imaginary will give you the content, and AND of that will give you the address, because scanf requires giving the address. I made a mistake in when I wrote down the program on that piece of paper, it should be AND out there. So is that okay? So we have given in two numbers, 2 points, the real part is 2.0, imaginary part is 3.9 of one number. Because in the program we first read in two numbers, so we are just reading in the two numbers, 10.0 and 12.5, and we get 12.0 plus j 16.40, whatever. Because the format is 5.2, therefore it will give it in this format. So just to have a look again at the program, you first define the types and define your new type called complex, and use that type throughout in complex declarations, etc., etc. This will lead towards what is called encapsulated. Here we have encapsulated the data, and now we are trying to put in functions which uses this data. And once we are able to encapsulate both the data and the function, we will get what is called a data structure. Suppose you could define a function where the main was manipulate complex, there was no main. This was the type definition, and these were the functions that you could use. And you would give it to somebody to say that here I am giving you a declaration for complex numbers, and I am giving you the functions for complex numbers. So this is called a data structure for complex numbers, a data type and the functions to manipulate on that data structure, on these data types. So coming back to our, just first the correction, this should be AND, because a dot, like a dot real gives you the value of the real number, a pointer dot real also gives you the value of that number. To get the address, since scanf requires address, you have to give AND. Now we need to understand something else. If I define int B 50, I define an array B of 50 elements, and B is the address of the array, the start location of the array, and we have seen the values of addresses in programs. If I define this, then I define B to be a pointer to an integer. Now this B in the array declaration cannot be modified. You cannot write B is equal to 55 inside the program. Alright, this B, this is not allowed, but this one is a variable. This B is a variable, and this B can be changed. This B can be assigned. B is equal to A plus 7, B is equal to B plus 1, B is equal to 25. All these can be done because this is a variable which is of type pointer to an integer. So when this is declared, 50 integers are allocated. 50 elements, each of the size of an integer, are allocated, and B is the address of this, and it's a constant. When this is declared, one element of size of a pointer, that is of size whose content can be an address. So its size will be the size of a pointer to an integer. What is a pointer to an integer? It is a content of the memory location. So its size will be the content of the memory location, and only one such is allocated. When we used it inside a function, say sort, we allocated only B, but we used the content, we got the value from here automatically passed on here, and this was used. We did not allocate more than that data, but we knew that from here the array starts and that array is stored in the memory, so we were able to use it. But here if you start writing down for this declaration, suppose I declare int star B and I write down content of B plus 5, okay, content of B plus 5, B plus 5 is the fifth element after this, is equal to 12. Don't think that the array, there is an array declaration here automatically of 5 elements. You have not declared any array here. You will be modifying the content of the location B plus 5, whatever it stores and wherever it stores. So you must be very careful about what is allocated in what declaration and what is a constant and what is a variable. Now we will come to another question. Suppose I give you a problem in which I tell you you have to sort n numbers. And the first thing I tell you is that n is less than equal to 100. Then obviously you will declare int data 100. But if I tell you read n and I don't know what is n, then the problem is what to declare. What size will I declare? 200, 300, 400, 900? Whatever you declare, the requirement may be more than that. So for that you need to dynamically allocate within the program. I need to allocate data. So we need to allocate data within the program, and this is called dynamic allocation. All right. Now unless you have dynamic allocation in programming languages, it will become difficult for you to define many such data structures. For example, if I define student records and you do not know, and you have got insertion, deletion, etc., etc., then even if you know that it will be less than 5,000, but on an average only 20 or 30 are used, then it is inefficient to declare a block of 5,000 elements of data. You are uselessly keeping that data, that area of the memory which is of no use to you. So you can even efficiently use data when you know that your requirement is always much less than your maximum, and you can use and allocate only whatever you require. So you can dynamically allocate or deallocate data. So in a programming language, in order to have more efficiency of implementation and use of space, you need to dynamically allocate and deallocate data, and it may be required even for problems where you will have to read in the size when required. So the next topics that we will talk on is on dynamic allocation.